All right, let's begin. Thank you everyone for joining in. This is our webinar on the latest happenings around the European transformers market, where we will discuss the impact of renewables and EV charging infrastructure. I'm Maliha Tariq, the Assistant Director Marketing at Power Technology Research. Over here, we have our two experienced market research analysts from PTR, Azhar Fayaz and Iman Ikhlaq with us, who specialize in the global transformer market research. The presentation today encompasses the power grid, expansion, market overview, supply landscape, and more. And of course, after the presentation, we do have some time reserved for the Q&A session. So please feel free to drop in your questions in the chat at any time during the webinar. We'll get to them after the presentation. With that being said, let's begin.
Thank you so much. Now, as we delve into the European transformer market and explore the profound impact of renewables and electrical vehicles charging infrastructure on this network, today's discussion will shed light on how the integration of renewables and the demand for EVs are driving the upgrade of power grid infrastructures, consequently fueling the demand for transformers, a vital component of the electricity supply chain. Now, as we witness an increasing integration of renewables into the power grid as a global push towards decarbonization, exemplified by initiatives like COP28 in UAE, which has set ambitious goals of tripling the renewable energy and doubling energy efficiency by 2030, it becomes evident that power grid expansion and modernization are paramount in achieving the net zero targets. Before we delve deeper into the European transformer market, let's outline the agenda for today's presentation. We will begin with an overview of PTR, Power Technology Research, and the services it offers. Following that, we will discuss the growing trends of decarbonization and its impact on the grid expansions. We'll also touch upon the investments in the European power grid and highlight new network expansion plans by major utilities. Later on, my colleague Azhar Fayaz will provide insights on Europe's distribution transformer market, supply landscape, and key market trends, particularly focusing on new transformer technologies. Now let's kick off by understanding PTR. PTR, a specialized market research firm established in 2016. The objective of PTR is to understand the recent and upcoming changes to our electric infrastructure while identifying and communicating the best technologies and associated business models applied by industry leaders. PTR focuses on two key areas, power grid and new energy. Now, to answer the question of what exactly is it that PTR covers within these topics. So a lot of the research that we here in PTR conduct are custom. So basically means that we are looking at what the customers have requested or what is the requirement of the customers and the demand, and we try to answer through our research. It varies from market sizing to competitive analysis to market accessibility. And oftentimes, we're providing a combination of all the three, and maybe a deep dive into one of these areas as per the client's requirement. Now, within market sizing, we look at the historical data, understand the outlook, as in comparing technologies against each other. Then we provide key segmentations of the market between technologies and application areas to try to understand them separately, as all of them are not really expected to show the growth in the similar manner. While within competitive analysis, we try to understand the main players in the markets in terms of market shares, SWOT analysis, benchmarking, and cost breakdown. Now, market accessibility is where we try to understand how the business is basically done, So our research is done on the country level, starting from business practices. We research what kind of regulatory framework network exists, what are the products and market trends, and what is the sales channel. Oftentimes, we have package reports where we combine all of these topics, customer requirements, we deep dive into the topic of interest. So basically, we help our clients in the energy sector with qualitative and quantitative information that supports their strategic decision making around business development. Now, other than custom reports, we also provide off-shelf reports. Within the power grid, PPR covers everything within and outside the substation, from transformers and switchgears to HVDCs and FACT systems. In addition to this, PTR also focuses on topics like port electrification, substation automation, and power factor corrections. On the new energy side, we are looking at the equipment that interacts with the grid. For example, EV charging infrastructure, energy storage, hydrogen as a power vector, and so on and so forth. Now, to do a deep dive into how transformer research is being conducted by PPR, we cover application. We cover different applications where growth is expected for power and distribution transformer. And these are the transmission and distribution sectors, generation sector, and industrial sector. Now, as discussed earlier, after these, we do a slicing of data to see which technology will experience growth in the future. And then the segmentation of data is done in terms of the insulation medium, voltages, scenarios. We look at the installer base to understand the historic trends, and then we look at the new additions to see what will be added in the future. Now, within PTR, power transformer addresses to transformers with voltage greater than 42 kilowatt. And within distribution transformer, it's from 1 kilowatt to 42 kilowatt. Now, that was an overview company PTR and the services that it provides its customers. Now, moving forward, the drive towards decarbonization, it is resulting in a need for expansions and modernizations of the power grid, which in turn is giving rise to the demand for legacy grid equipment and components, including transformers. Now, one of the key components of decarbonization, the key component of decarbonization is the increased adoption of renewable energy sources, which are essential for reducing greenhouse gas emissions. The penetration of renewable energy sources has increased significantly in recent years, with many countries having ambitious targets for their adoption. Now, this is driven by a desire to move away from fossil fuels and towards a more sustainable energy future. Another key component of decarbonization is the increased penetration of electrical vehicles, leading to a growing network of charging infrastructure. Grid expansion is necessary to accommodate the growing demand for the renewable energy sources and to support the infrastructure required for the electrical vehicles. Now, as we have established that the modernization of the power grid is crucial to enable the integration of renewable energy sources and to ensure the stability and reliability of the grid. Now let's have a look at historical figures of renewable energy in the last 5 years within Europe and what is expected for the next 5 years. So if we talk about the total renewable capacity additions in Europe, in the last 5 years from 2019 till 2023, 272 gigawatts were added. However, in the next 5 years, the capacity of about 450 gigawatt is expected to be added, and this is going to be a 65% increase in the capacity addition from the historic period. Now, if we do a further breakdown of the total capacity, the solar PV accounts for 70% of the expansions, while wind accounts for approximately 26%. And when we look at utility scale solar capacity, we see that there's also movement there with the capacity addition in the forecast years of 2024 and 2028, and it is expected to be 94% higher than the case in the last 5 years. Similarly, for wind capacity, in the next 5 years, the capacity addition will be 42% higher from the historical period. However, we do see that the forecast for offshore wind has been slow because of persistently long lead times and concerns over the future project's economic attractiveness. Now, these additions in the capacity in Europe region are due to its ambitious targets to achieve 45% renewable share in the energy mix by 2030, with 600 gigawatts solar PV and 480 gigawatts wind. Now, this movement within Europe is going to drive up the demand for the legacy grid equipment as utilities look to expand and modernize their grid to incorporate not only the additional capacity coming from renewables, but also this capacity which is variable and calls for multi-directional flow of electricity. Now, as we've discussed, that the expected capacity in the future is increasing, so they are going to be driven by the targets of each of the key countries within Europe. Now, let's take some of the examples. Within Germany, Germany aims to have 100% of its energy from renewable sources by the year 2035 and will be having a total of 215 gigawatts of solar and 115 gigawatts of wind capacity by 2030. Now, within France, the French law has set a target of 40% renewable energy in electricity generation in 2030, with 60 gigawatts of solar PV capacity by 2030 and 18 gigawatts of offshore wind by 2035, which will lead to 40 gigawatts by 2050. Within the United Kingdom's aim to generate 60% of its electricity from renewable sources by 2030 and is also aiming to achieve 50 gigawatts of offshore wind and 40 gigawatts of solar capacity. Similarly, Spain also aims to install 76 gigawatts of solar PV and 62 gigawatts of wind power by 2030. Now, finally, when we talk about Italy, Italy aims to generate 65% of its electricity from renewables by 2030 and is expanding its installed renewable capacity to 131 gigawatts by 2030, with an addition of 80 gigawatts of solar PV by 2030. Now that we've discussed the renewable energy targets, now the second major step towards decarbonization is the electrification of the transport sector. We see that there is a push towards adoption of the electrical vehicles in order to achieve the climate and net zero carbon goals. The EV charging market is currently an incentive-driven market. So now let's have a look at some of the key countries within Europe, their EV targets and incentive and policies. Now looking into Germany, Germany plans to install 1 million public EV chargers by 2030 with an investment of 6.8 billion. The Germany government has also approved 6.3 billion euros till 2025 to scale up the EV charging station. France, on the other hand, aims to have 2 million electric and hybrid cars domestically and 7 million charging points by 2030 and will be investing $113 million funding for the fast charging stations. Now, if we look into the incentives that the France provides, France is providing tax exemptions and reductions for the residential, workplace, and public charges, and also 100 million euros to facilitate EV infrastructure. medium to rural density commute. Now looking into United Kingdoms, the UK is also expected to grow rapidly with the announcement of 50,000 to 190,000 street chargers. It is also investing 1.9 billion euros in charging infrastructure and consumer incentives, and also smart charger features regulations. Spain. Now within Spain, fuel supply facilities are obliged to install EV chargers with limited exceptions, and the National Energy and Climate Plan aims to add 5 million EVs by 2030. And finally, within Italy, they provide subsidies for the purchase and installation of EV chargers, and alongside that, is also providing 110% tax credit under super bonus. Now, as we have covered the decarbonization, we will look into the power grid investments in the recent years of the Europe. For Europe, and from year 2022 and 2023. One thing that is immediately clear is that investment in 2023 is almost doubled the amount of that in 2022. Now, that can be explained by the need to expand and upgrade the grid infrastructure due to the growing due to investments in the utilities. And we can see that Germany invested 3.2 billion USD. France invested 3.65 billion USDs, and Spain invested 2.6 billion USD within the year 2023. However, there's still a need for much higher investment. So there is definitely, if we look into the grid investment, we see that there is no future for Europe without an upgraded power grid. Without a power network fit for the purpose and ready to integrate the surge of renewable energies, you will neither be able to achieve its energy climate targets by 2030 nor reach its green goals. So distribution grids are the technical enablers behind most of the Europe's requirement to set in the Europe's green deals by connecting millions of customers to the growing number of solar rooftops, PVs, and other new generation capacities. So in short, utilities are facing significant challenges as they work to achieve decarbonization and electrification goals. So upgrading the old infrastructure and increasing grid capacity will be critical to achieving success. And we see that in the future, we do expect an investment trend to grow. Europe also plans to unlock 584 billion euros in the grid investment by the year 2030 to upgrade the old infrastructures. Now for the overview of grid expansions and plans. 40% of the Europe's distribution grids are over 40 years old, and they need to be modernized. Industry estimates around 375 to 425 billion euros of investment in distribution grid that are absolutely necessary by 2030. The recovery and resilience plans have allocated around 13 billion euros to grids, covering reforms and investments in grid infrastructure, smart energy system, energy storage facilities, and digitalization of distribution and transmission networks. EU Action Plan digitalization of the energy system also hopes to invest $633 billion in the European electricity grid by 2030, with 184 billion going towards digitalization, such as smart meters, automated grid management, and improvement to field operations. In the meantime, by 2035, RTE plans to invest 13 billion euros in transmission and sub-transmission networks, 8 billion euros for replacing the old infrastructure, 7 billion euros for connecting marine energies, 3 billion euros for grid digitalization, and 2 billion euros for cross-border interconnection. RTE is a TSO in France, but it also provides a distribution service. Now, to sum it all up, we have looked at how the renewable and electric vehicles are shaping the Europe's transformer market, with decarbonization, the rise of renewable energy, and the growing EV infrastructure are driving the need for grid upgrades and consequently transformers. This shows the vital role of transformers and the vital role that they play in our energy future. Now, I will pass the baton to Azhar Fayaz to delve deeper into the Europe distribution transformer market and key market trends. Azhar, over to you.
Thank you, Iman. With all these investments being done to mitigate grid challenges, it's definitely the need of the hour to upgrade and modernize the power grid. This will eventually drive the demand for legacy grid equipment, including distribution transformers. Now, if we talk about the global distribution transformer market, then the global market in 2023 was valued at $26 billion. Zooming into the regional breakdown of the global market, the total distribution transformer market in APEC region accounted for almost 50% of the global market, which is a huge share. So it's safe to say that any movement in the APEC region will have an impact on the entire distribution transformer market globally. Now, if we talk about the European distribution transformer market specifically, then in 2023, the transformer market size was about $4.5 billion, especially after the Russian crisis, when the emphasis is to replace conventional power generation with wind and solar. Installation of EV charging infrastructure in the region, especially in Western European countries, is also instigating the expansion of distribution grid and driving the distribution transformer market eventually. Now, if we talk about the Nordic countries, then with 40 years old grid infrastructure, they will also foresee huge investments in the replacement of grid equipment, including distribution transformers, hence driving the market demand. So these replacements plus new additions due to the renewables and EV charging infrastructure are going to drive the market with 5.5% growth rate, and it is eventually cross $6.5 billion mark by 2030. Now, if you look at the voltage split of the European distribution transformer market in 2023, then most of the demand is coming from 13.5 to 24 kilovolt voltage range, followed by 1 to 12 kV voltage level. Now, majority of the distribution system operators in the region, they have three-phase pad-mounted transformers installed in their network infrastructure with an average size of 600 kVA as compared to other regions. Then the US market is marked by the installation of single-phase pole-mounted transformers with an average size of less than 50 kVA. So US and the European market, they are the two extremes of the distribution transformer market. Europe is marked by the presence of three-phase pad-mounted transformers, while US is marked by the presence of single-phase pole-mounted transformers. Another important trend in the region is the prevalence of oil-type distribution transformers, which contribute an average of 82% to the total annual revenue. Now, it is anticipated that the share of oil-type transformers will further increase in the coming years due to ester-filled transformers replacing dry-type transformers. These ester-based transformers basically lie under the domain of oil-type transformers, and for now, EU is actively deploying these ester-filled transformers on pilot project basis, but they are anticipated to gain traction in the future. As a result of this, dry-type transformers market share will further reduce in the future. Now, if we talk about the vertical split, then we can see from the pie chart that most of the demand for distribution transformers is coming from utility sector, which is approximately half of the $50 billion market in 2023. Now, not only does Germany has a huge volume in terms of its market size, but it's also expected to grow at a very fast rate by 2030. Then finally, we have UK and Spain with 270 and 250 million US dollars market in 2023. As we all know, globally, transformer suppliers are facing significant challenges in their supply chain, ranging from increased material demand to labor constraint factors. These issues have led to significant longer lead times, and as a result of this, prices have increased remarkably for the end users. Therefore, it is very important to understand the supply landscape of European distribution transformer market in order to recognize its local production capabilities and import and export scenario. Now, If you look at the import and export data of Europe's distribution transformer market for 2022, then approximately 135,000 MVAs of distribution transformers were imported, while 145,000 MVAs were exported out of the region to other countries. Now, it can be seen from the figure that the Europe has sufficient local production capability of distribution transformers and can meet the annual market demand if needed. Now, some of the major manufacturing hubs of distribution transformers in the region are Germany, France, Turkey, and Ireland. And we know that like all major distribution transformers manufacturers in the region, such as Hitachi Energy, Siemens Energy, Kite PowerTech, they all have got their bases in these major manufacturing hubs in the region. Now, if we talk about the import of the distribution transformers, then APAC region is the leading source of imported distribution transformers for the European market, and mainly from India and China, these transformers are sourced. If you talk about the exports, then Europe exports almost similar amount of distribution transformers in terms of MVS to Americas region, mainly Latin American countries, which includes Brazil and Chile. Now, Brazil is the largest market in the Latin America, whereas Chile has a highest growth rate in the region due to all this about the renewables. So there's a huge momentum in Chile's renewable energy market, and that is what driving the demand for distribution transformers. However, if you look at the supply capacity or the lead times of distribution transformers in the Europe, then I would like to compare it with the US market. So in the US market before COVID-19, distribution transformer lead times used to be like 8 to 10 weeks, both pole and pad mounted. But at present, the situation is very bad over there, and the lead times have increased to like 1 to 2 years from few weeks. However, if we talk about the European market, then it still has sufficient supply capacity, and it has a lead time of 16 to 18 weeks time frame, unlike US. So the situation is good in the European market for both like oil and dry type transformers for pole and pad mounted transformers. Now, if we look at the top five distribution transformer suppliers in the region, then we have Siemens Energy and Hitachi Energy at top, followed by SGB Smith, Schneider Electric, and or Mazabal. So these suppliers have significant market share due to their presence in the top regional markets such as Germany, France, etc. A prominent trend in the European market is that suppliers who manufacture locally in each country have the highest market shares in those countries. And this is not necessarily due to the local content requirements, but rather due to the proximity to the customers. So customers usually prefer those suppliers who have got their manufacturing bases or their sales team located near to them, so that they can avail the after sales services even after the purchase of or the procurement of the distribution transformer. For example, if you talk about the Germany, then SGB Smith and Siemens Energy, they have the largest market share. Similarly, in case of France, Schneider Electric or Mazabal, they are the biggest players. Now, due to the another important trend that is very, you can say prominent in the European distribution transformer market is the technology awareness. So end users usually prefer those suppliers who are embedding their existing product portfolios with latest technology like digitalization and artificial intelligence, etc. Such suppliers have been able to penetrate the market more efficiently in the recent past. So let's say if we talk about Hitachi Energy, then it enabled its TX for transformer digitalization solutions with artificial intelligence back in 2023. It also launched a special a special distribution transformer with TVP technology for data centers and renewables market back in 2023. And as a result of this, now Hitachi Energy distribution transformers are much preferred by both data center operators and renewable developers because of this TVP technology. Similarly, in 2022, Schneider Electric launched its EcoStructure Transformer Expert platform, which was designed for transformer monitoring. Now, discussions have revealed that most of the end users they prefer Schneider Electric Transformer because of its EcoStructure platform. So these technology trends they play a very important role in expanding market shares, in winning contracts, and all of that. Now, let's talk about some of the key market trends of European distribution transformer market. Within this, I am first going to touch upon the topic of carbon footprint. So when it comes to the transformer carbon footprint, the focus has always been on the CO2 emissions linked with the transformer operation, which basically means transformer efficiency. And this is also evident from the Eco Design Directive, which only has addressed transformer efficiency till now. So, according to a survey conducted by EU Commission back in 2008, the annual transformer losses accounted for like 2.9% of the total energy generated across EU 27 and the UK. And this energy is equivalent to 93.4 terawatt hours, which is the amount of energy consumed in Denmark over the time span of 3 years. So in order to reduce this energy losses from 93.4 terawatt hours to 16.2 terawatt hours by 2025, an eco design directive was put in place in July 2025. And this directive basically specifies the rules and minimum efficiency requirements for both distribution and power transformers, and it applies to all transformers placed in the market or put into service in the UK and EU. And this, however, I would like to highlight, like, this directive does not get applied to the already existing installed base of distribution transformers. It only applies to new transformers coming in the market. Now, since this Eco Design Directive was put in place back in 2015. A revision of this directive Tier 2 was then implemented back in July 2021 with an aim to reduce energy waste by further 10% compared to 2015 levels. Now, there are some discussions in the market, like Tier 3 of this Eco Design Directive is also under this discussion, and it is anticipated to be implemented by 2027. Now, as I discussed already, like historically, the focus to, the way to reduce the carbon footprint of transformer has always been on, increasing its efficiency and improving the operation of a transformer. But now this trend is shifting towards the manufacturing of distribution transformers as well. So I'm going to touch upon the topic of green raw materials, which are being used nowadays in transformer manufacturing, and they offer more sustainable, environment-friendly alternatives to traditional materials. So on top of it, we have ester-based fluids, which are used as an alternative to mineral oils in the market. Another example is green steel, which is produced using recycled materials and renewable energy sources such as wind or solar power. By using green steel, manufacturers can reduce their carbon footprint enormously, and environmental impact will also be reduced compared to the traditional steel manufacturing methods that rely heavily on fossil fuels. Other examples of green raw material used in transformer manufacturing include plant-based insulation materials such as cellulose and soy-based foam, as well as recycled copper and aluminium. So all these materials, they offer sustainable alternatives to traditional insulation and conductor materials, which are typically made from non-renewable sources. So basically, what's happening is manufacturers, they are shifting their focus from using high efficiency or designing high efficiency transformers to using green raw material, using carbon friendly raw materials which are being manufactured using these renewable energy sources and not from conventional fossil fuel based sources. So this is definitely going to result in a reduced carbon footprint of our transformers. Now, if we talk about since in the previous slide we talked about the mineral oil alternatives, that is ester-based transformers. So I'm going to deep dive into this ester-based products. So utilities, governments, companies all have nowadays set a target to achieve a sustainability goals, and they are trying to work on sustainable practices which can be adopted in the future. And along these sustainable practices lines, like there's a lot of talk around ester-based products in the Europe. For now, these ester-based products or ester-based transformers, they are being discussed in the Europe and Americas region, but it is anticipated that they will gain traction in the APEC and the Middle East Africa region in the coming future as well. So if we talk about some of the major properties of these ester-based products, then we and on the top of it we have like it is biodegradable, it is non-toxic, and these two factors basically support the notion that ester is sustainable and climate and neutral environment friendly. Similarly, its thermal aging property is much better than mineral oil, which give it a longer lifespan. So if you have a transformer with ester oil and another transformer with mineral oil, then the lifetime of a ester oil based transformer will be much more than the conventional mineral oil based transformer. Similarly, if we talk about the fire safety, aspect of the ester-based transformers, then the flash point and the fire point of this ester is very high compared to mineral oil, as a result of which it reduces significantly the requirement of safety equipment where the transformer is being installed, and it is extremely suitable for the indoor environment. Uh, Having said that, let's talk about some of the key market trends around ester-based transformers in the Europe. Now, if you talk about some of the specific trends, then at present Europe has a very small install base of ester-based transformers, but there is a clear trend in the European countries for the adoption of ester-based transformers. For now, like many utilities are installing these on pilot project basis to assess their profits, to assess the benefits they can reap from this new technology. However, in case of UK, I would like to highlight like some utilities are installing exclusively these ester-based transformers. Similarly, if you talk about the ester, then there are two types of ester. One is natural ester and the other one is synthetic ester. So synthetic ester is the one in which the properties of natural ester are, you can say they are increased using different sort of additives. And if you talk about the Europe, then European utilities are more inclined towards using synthetic ester-based transformers than natural ester-based products. Like they want the increase or enhanced properties of ester. Another important, you can say, aspect, another important key market trend is that like in the Nordic region, renewables are considered a bigger market of ester-based transformers than the utility sector. And if you look at the top market for ester-based transformers in the Europe, then we have got Germany, Sweden, Netherlands, and Poland. And these markets are basically driven by the fire safety regulations. This that was about like the key market trends of ester in the European market. Uh, Now, if you look at manufacturers, then most of the transformer manufacturers have realized this shifting trend and they have started offering ester-based transformers in their product portfolios. Some manufacturers have even started, offering them in much you can say majority than mineral oil based. For example, like 80% of Westrafo's manufacturing capacity is for ester-based transformers, while only 20% is for mineral oil based transformers. And according to Westrafo, since they have started offering ester-based transformers, their revenue has skyrocketed. Uh, that was about the manufacturing side. Now, if we talk about the supply chain, then due to this flourishing ester market, Shell, which is the we all know about Shell, right? It's a huge market, huge player. So it has recently acquired Midel and Mivolt, basically the ester product lines of M&I material, because they have expectation like ester is going to gain a lot of traction in the future. Lastly, I'm going to touch upon the topic of digitalization, like how digitalization is penetrating the distribution transformer market. So let's first talk about the digitalization, like why is it important? And I would like to say like it is important not just for the transformers, but the power grid as a whole. It is fundamental to support EV adoption and renewable integration. Now, there are a couple of aspects of digitalization of the power grid that I'm going to discuss. So let's begin with the concept of smart grid, where the key is to collect data and then use this data to intelligently integrate and manage all these renewable energy sources. So we need smart grid management for renewable energy sources integration. Then there's the concept of load management, specifically for electric vehicles, where there's passive and active charging concept. So passive charging is when you shift your peak load to off-peak charging hours using thermal fuse charging mechanism. And then active charging is when you collect all the data from the power grid and then you use, sort of algorithms to then you use algorithms to efficiently use your power grid. So in order to do that, you need to measure or monitor different nodes of the power grid, and for that you need digital transformers. Now, if we compare Europe to the other regions, then the Europe leads the adoption of digital distribution transformers. In 2023, according to PTR, Europe accounted for almost 28% of the global data distribution transformer market and is expected to grow at a CAGR of 22% by 2030. Now, PTR conducted a survey to understand what kind of digital transformers are preferred by end users, and the replies indicate majority of the end users in Europe prefer advanced digital transformers, which have all the features that includes remote monitoring capabilities. And are also embedded with like some online platform for application layer analysis. Now, for that, the end users are even willing to incur 20% additional cost. Um, if you look at some of the main growth drivers for data distribution transformers in the market, then definitely electric vehicles and renewable energy, these are the major ones, which are forcing utilities to shift from model-driven system to data-driven system to the data-driven one system at a distribution level. So historically, utilities used to have some infrastructure in place using some assumptions, but now these renewables and EVs are changing, the scenarios in real time and are forcing utilities to shift from those assumption-based model to real, data-based models. Furthermore, like COVID-19 pandemic, it has also helped realize the utilities and end users the importance of remote monitoring and predictive maintenance and control as well. So that is why the European users are now going for data distribution transformers. Another important another important point that I would like to highlight is compared to other regions, the end users in Europe are much more educated about the benefits of digital distribution transformers, and the credit for that goes to transformer suppliers, transformer OEMs, who have played an important role in conveying or educating the end users the importance and benefit of these transformers and the benefits that they can get from it. However, like these were the definitely growth drivers of data distribution transformers, but there are some barriers as well. And generally speaking, digital power transformers are more common than data distribution transformers. Uh, and the reason for that is most of the time, like people have this conception that distribution transformers like they are easily replaceable. They can be easily found. They have sufficient inventories of the distribution transformers, and even if it fails, like they can replace it. So they don't need to, have the active monitoring of distribution transformers. On the other hand, if you talk about the power transformers are custom designed and the lead times of transformer at least takes like 1 to 2 years. So that's why they need to monitor the parameters of digital power transformers, and hence that's why we see uh, digital power transformers are gaining more traction than digital distribution transformer because of the concept of easy replacement. That was about the European distribution transformer market. Now, if you have any questions, then please let us know. Thank you.
All right. Thank you so much for the amazing presentation, guys. Let's start taking the questions. All right. So the first question is, which European country or region has the highest onshore and offshore installed wind capacity additions?
Yeah, so I'll answer that question. So within Europe, we see that it is an uneven production. So like two-thirds of Europe's wind power is installed in just 6 countries. So the major ones would be your Spain, France, Sweden, Italy. And some major reasons of these are that these countries have large land areas and extensive agriculture landscape where obviously the turbines may be located more readily, and as well as they have access to considerable offshore resources. And another reason is that European Union has now brought in new rules to simplify the permitting process. So in Spain last year, they awarded 70% more permits for the onshore winds than done in previous years. So due to these reasons, I would say the major countries within Europe would be Spain, France, and Sweden. Yeah.
All right. All right. The second question is, how many distribution transformers, not in revenue, in quantity, are taken into account for 2030?
So I'll be answering that. So if we look at the total distribution transformers numbers that are going to be sold in 2030 in terms of units, that's going to be roughly 500,000 units. And when we say distribution transformers, we are talking about those transformers, uh, the voltage range of which lie in the range of 1 to 2 kilovolt. So we are specifically talking about 1 to 42 kilowatt range distribution transformers, and that would be in the range of 500,000 units by 2030.
All right. The next question is, what are the five key manufacturers in Europe and related competitors for distribution systems outside of Europe?
I believe that has already been addressed in the slide. We did mention the top five manufacturers of transformers or the suppliers in the Europe region.
Okay. Next question is two-part. Are there any statistics available for decommissioned transformers nearing the end of their lifespan?
Yeah, we have. So when I say like towards the end of by the end of 2030, we are going to have like annual sales of 500,000 distribution transformers. So in that annual sales, we are talking about both new additions as well as the replacements of end of life, like replacements of transformers which have reached their end of life time span. So at present, roughly like 2 to 2.5% of the total install base is being replaced. uh, uh, and if we talk about 2030, then definitely it's going to increase a bit. And if we look at the number of units, then in terms of units, at present, the number of transformers that are getting replaced in Europe, it lies in the range of 200 to 250,000. So
Okay. The second part of the question is, could you please clarify whether the figures provided pertain exclusively to brand new transformers? The number of transformers approaching in the end of their operational lifespan is significant currently.
So just like I said, when we talk about these numbers, so we are taking into consideration both new additions, which are the like brand new transformers, as well as the replacements of the old transformers, which have reached their end of life.
Hmm. Are there any issues that Europe is facing in meeting its EV targets? What are the hurdles?
So I'll be answering that question. So Europe does have quite ambitious targets for EVs, like 30 million EVs by 2030. It also, which is to ban the gas-powered cars by 2035. Uh, and there is growth. However, recently we did saw that there was some sluggish sales within Europe. We have already established that EV is an incentive-based, incentive-driven market. So any reduction of subsidies for the electric vehicles in countries like Germany because of the government budget problems will result in sluggish sales. So we saw that recently Berlin ended a 7-year subsidy scheme, which was known as environmental bonus, in which the consumers get a purchase grant of several thousand euros when they bought EVs. Now they've ended that scheme. Also, a few months earlier, the government had already also ended the subsidy scheme for corporate fleet buyers, which actually accounted for like almost 2/3 of German car market. So we do see a sluggish sales in Germany and overall Europe almost like 70%. But I see this as more of a bump in the road rather than a serious problem because we do expect more affordable models to come by 2026. So the forecast will definitely grow by then. Yeah.
Right. And the next question is slide 21 was referred to Europe or US?
So this like slide 21, in slide 21, we are talking about the import and export figures of the European market. So that was specific to Europe. Uh, Here and there in the presentation, I did bring up US market because I was making comparison of European market with the US where transformer, like there's extreme shortage of transformers. So that's why I was just making some comparisons.
All right. Okay. Then the next question is, what is the amount of replacement because of age and what amount because of changed requirements?
What is the requirement? I believe I have answered this question as well. Like if we talk about the replacements of distribution transformers, then in terms of like units, the number is somewhere in the range of 200 to 250,000 units at present.
Right. What are the typical lead times and expected for 2020 for distribution transformers up to 50 MVA in Europe?
So I believe like by 2020, like we are going to talk about like three time spans, like before COVID-19 pandemic, what happened after the COVID, and how do we foresee the for like future. So before COVID-19 pandemic, the lead times of distribution transformers used to be in the range of 8 to 10 weeks time frame. like before 2020, I would say. Then after the COVID, there was some supply chain constraints. There were some issues because of which the lead times of transformers increased to, let's say, at present they are in the range of 14 to 16 weeks time frame. Like they have increased a bit, and in the future we see we believe like there would be increase in demand for distribution transformers, but the supply chain constraints would get resolved, and like lead times would also return back to their normal time frame, which is like 8 to 10 weeks, I would say. And the reason for that is we have been seeing a lot of investments from transformer manufacturers in distribution, in both distribution and power transformers. So manufacturers have been expanding their existing facilities, opening new facilities, which also indicates that manufacturers see all this increased demand in the market as a sustainable. They don't think like this is something which is short term. Rather, they see this as a long term demand and think of it as a sustainable demand, and that's why they're investing in these facilities. And when these facilities will start manufacturing, let's say 2 to 3 years from now, then definitely by the end of 2030, there will be sufficient supply capacity, and the lead times be will be back to normal time frame, I would say.
All right. What are the expected capex percentages, increases and decreases, trends in Europe for distribution transformers?
Mm, to be honest, I didn't get this question. But if it's about like the grid investments that are supposed to happen in the European market, then we believe like in the coming years, Europe is going to invest significantly in the, I would say, distribution segment. So let's say if we talk about renewables, so the pace at which interconnected renewables are coming online, that's more than the current grid infrastructure was built with its stand. So in order to accommodate all these renewables and EV charging infrastructure, investments need to happen. And we believe like in the coming years, a lot of investments are going to happen in the European market. So for example, if we talk about the Spain, then yesterday Spain launched, I guess, yesterday it announced a plan in which it says like it's going to Iberdrola. Let's say if you talk about Iberdrola, the DSO in the country, it signed a $700 million loan with European Bank. So that investment is going to go into the grid. Total investment under the projects amounts to 1.44 billion euros. So all this investment shows like Spanish market is going to boom. Similarly, if you talk about the French market, then Enedis announced that it's going to invest roughly 4.4 billion euros by 2032, like on annual basis. Like earlier it used to be 4.4 billion dollars now, but now they have increased that investment from 4.4 to 5 billion dollar. So all these trends indicate like there's going to be significant investment in the distribution grid of the European market, and that's going to drive the demand for both distribution and power transformers.
Okay. What is the definition of digital transformers and what is covered in it?
Okay, so we did a sort of survey, I would say, and we were looking at three types of data transformers. So tier one transformers were data transformers were conventional transformers with some you can say monitoring sensors. Then there was tier two data transformers in which we were looking at like monitoring sensors along with remote monitoring capabilities. Like you are able to get that data and different parameters from somewhere remote. You don't have to go to the site. And then there was tier three, or the most advanced data transformers, in which you have the sensors installed on a conventional distribution transformer. Then you have got the remote monitoring capability, and you are sending that data to some you can say online cloud, where the application layer analysis of that information that you are sharing is happening. So when we talk about the data distribution transformers, in case of Europe, we found like most of the end users, they prefer the advanced data distribution transformers with all these possible features where they are able to gather all their data remotely and then process the data and get the application layer analysis of like what's the remaining lifetime of transformers and all.
All right. Next question is when it comes to digitalization, highlight one major aspect that is expected to undergo more significant advancements.
So if I say like in the context of digitalization in the transformer industry, advancements are expected to occur across the various areas and aspects, like both in high voltage and low voltage applications. Uh, it is challenging to predict the exact timeline for specific advancements, but like I can comment on one of the major aspect that is going to change, and that is cybersecurity and protection. So as transformers become increasingly connected within the detailed networks, uh, ensuring robust cybersecurity measures, it's becoming of extreme importance. So digitalization necessitates secure communication protocols, encryption techniques, and robust protection mechanism to protect transformers from cyber threats. So this is one of the major aspect which is sort of impeding the adoption of data distribution transformers or both digital power transformers, and that's going to be addressed more rapidly in the coming time frame.
Okay. Is the adoption rate of ester-based transformers high in power transformers or distribution transformers?
Okay, so if we talk about the growth drivers of ester-based transformers, then definitely environment carbon footprint is one of the reasons, but there are some other reasons like ester-based transformers, they are much more reliable than the mineral oil-based transformers. And if you look at this from reliability perspective, then generally network indicators like SIFI and SID values of power transformers indicate like power transformers do not undergo much failure than distribution transformers, which grow relatively more. So the adoption rate of ester-based transformers in distribution transformer is high than the power transformers, as indicated by the network indicators. And another important reason for that is most of the time, like ester-based transformers are installed in underground applications or indoor environment, and that's where we have like distribution transformers. Usually, we don't have like power transformers in underground or indoor environment. So that's why ester-based transformers are more common in distribution transformers.
Does distribution transformer demand forecast based on investment or calculation based on number of renewable energy source such as wind to- tower and solar farm?
Okay, so basically we need to comment on the like how do we forecast the total number of distribution transformers, right? So we have proper models in place, like we look at the number of transformers that are expected to come online from industry vertical, generation vertical, and the utility segment. So for the generation segment, we look at the number of renewables gigawatts that are expected to come online in a specific market. For the utilities, we look at the investments being done by the utilities or the distribution companies in that particular market, and then we take those investments into account and then base our forecast on different investments that are happening in that specific market. So for example, let's say if we talk about the European markets, then we are taking into consideration not only the renewables, the set target of the renewables, but we are also taking into consideration EVs targets. We are also taking into consideration different investment plans announced by the distribution companies, transmission companies, and all of that, in order to connect the dots and then make a complete picture out of it.
Right. Next question is from Vishal Jogi. What about power transformers? Can you please elaborate this a little while I move on to the next one?
So
Okay.
if we talk about the power transformers, this particular webinar was about distribution transformers. For power transformers, it would be great if you reach out to us with your specific questions on power transformers, and we'll be happy to help you get back to you.
Right. What's the maximum voltage rating of HVAC and HVDC systems in Europe and maximum generator voltage?
Maximum generator voltage. I'm afraid I don't have answer to this question right away. Please drop your email and we'll get back to you with this.
Sure. Okay, there's another question. What are the five key manufacturers in Europe and related competitors for distribution systems outside Europe? What are the biggest manufacturers, competitors outside of Europe? Sorry if I missed that earlier.
I no, you already asked this, so like
Yeah,
we have already addressed this question in our webinar. Like there is a slide in our
understood.
webinar. We are talking about the top 5 players.
Mhm. What is the trend of amorphous distribution transformers in the EU?
Uh, for now, I would say like the trend of amorphous distribution transformer, like uh, I believe I was going through an article and I found a UK based manufacturer who announced like they have started manufacturing amorphous based transformers. But I would say this trend is much more common in the US market because where DOE is pushing the manufacturers to shift towards amorphous core, it's not related to Europe. It's more outside the Europe, I would say. Though this is like there are some manufacturers here and there in the Europe region who sorry about that, who have started manufacturing amorphous core based transformers, but I would say it's more relevant to the US market than the European market.
Right. The next question is, what is the forecast of power transformers market in Europe in terms of needs from the grid and investment from manufacturers?
Sorry, can you please repeat that?
Sure. What is the forecast for power transformers market in Europe in terms of needs from the grid and investment from the manufacturers?
Again, a question related to power transformer. We'll get back to you on that after the webinar.
Okay. All right. And then there's an explanation about a previous question. What are the expected capex percentage increase or decrease trend in Europe for distribution and power transformers? This question aims to understand if the cost trend of transformers will show an increase or decrease in percentage.
Okay, so it's about like the how the cost is going to evolve of transformers in the coming years. So if we look at the cost of the pricing analysis of transformers from different raw materials perspective, then it's going to experience an year-on-year increase of 3 to 4% in the coming years. I would say we don't foresee like any abrupt jumps in the prices of transformers as we experienced in the previous couple of years, I would say.
All right. Okay. Then one last question. What are the typical expected lead times for 2030 for transmission transformers in Europe?
For basically for power transformers in Europe, lead times. So let's say if we talk about the power transformers, let's take this question. So like across the globe, power transformer manufacturers, they are booked, and like they are booked for the next 2 to 3 years, as disclosed in multiple discussions. So if we talk about the lead time, so let's say if you are a renewable project developer and you go and look for a power transformer procurement, then you will face a lead times of 2 to 3 years at least. Uh, Usually, like before COVID-19, it used to take like 12 to 14 months time, and which has significantly increased nowadays. So by 2030, just like I said, we have been seeing a lot of investments being done by the manufacturers, in both power transformer and distribution transformer facilities. So it is expected that the supply demand gap in case of power transformers, it will get addressed by 2030, and we will see lead times return back to their normal time frame, that is like 12 to 14 months for a power transformers.
All right, that's about it. Thank you very much, Iman and Azhar, for answering all of the questions. And thank you, everybody, for joining in for this webinar. During this week, an email will be sent out to all of the registrants for the webinar with a link to the presentation and, of course, the recorded webinar itself. So stay tuned for it. And that's it. Thank you very much. That's adjourned.
Thank you.